أنا اللي سعيد بكم.
الله
مشكور على
يسلمك.
الدعوة، مشكور على الاهتمام.
الله يعطيك.
هذا الموضوع الشيق.
الله
دائما بشوفكم في الطليعة والله يحفظكم.
الله وإياك دكتور، الله يعطيك العافية إن شاء الله.
الله يوفقكم جميع أعمالكم إن شاء الله يا رب.
احنا نحب نرحب اخواننا بعد البريك القصير جدا اللي نستأنف المحاضرات. عندنا 4 محاضرات يعني شيقة ومميزة. راح نبدأ مع الدكتور مصطفى التومي، وبعدها راح يكون معنا الدكتور هاني محسن، وأيضا معنا الأستاذ عمر مسعود، وأيضا فرانكو جوفي، بمواضيع جدا شيقة. We'd like to welcome you back, guys, for our continuing sessions. We will start with now with Dr. Mustapha. He's a senior advisor in the EU GCC Clean Energy Network, and we are always glad to have him to gain from his experience, and I hope you will enjoy his speech. Dr. Mustapha, تفضل. You can start now.
شكرا جزيلا باشمهندس سالم، شكرا على الاستضافة، وسعيد بلقياكم كالعادة، وسعيد كذلك أنني متواجد مع هذا الفريق، فريق العمل عندك يعني متميز جدا، وأتمنى أن البرزنتيشن يعني ترق للجميع وتكون الاستفادة للجميع. خلينا أعمل شير سكرين وأتكلم بالإنجليزي إن شاء الله. Good evening, everybody. I'm pleased to be with you this evening, and I would like to thank Engineer Salem and Dr. Ashraf and all the colleagues for their invitation. So today I will talk about renewable energy. Of course, this is the topic of this webinar, but what about the current situation and the perspective? So just an introduction, I wanted to mention this wise quote from Nelson Mandela. Action without vision is only passing time. Vision without action is merely daydreaming, but vision with action can change the world. That is the message that I want also to vehiculate during this presentation. Is for renewables, we need a vision, but we need also an action. So regarding the energy transition, as we are all talking those days, and since the Paris Agreement in 2018, it was obvious that we have to go forward with this energy transition. So the key pillars, the 3 pillars of this transition is decarbonization, digitalization, and decentralization. And inside this framework, we have to deal with policy, with finance and investment, and also technology and innovation. On top of this, we have also to tackle the issue of the data, the availability of data, and we are handling a lot of data coming from our project, or all the facilities in energy and other sectors. Knowledge management is key also, as we have to learn and we have to take, note of all the changes, all the experiences, the failure and successes, and this is very important for the next generation. For this energy transition, we need to also work on all the sectors of the economy, not only on the power sector. So we have also the other sectors like transport, building, and industry that are consuming energy. And if we need to go with 100% of renewables, we have to also transform those energy on clean energy. So since, as I said, the Paris Agreement, energy transitions have gained traction around the world. Efforts are underway in many countries in our MENA region, but also in Europe, in America, in Asia, to advance green economy, green concepts, and reduce the carbon footprint for the main sector of the economy, including the energy or power sector. Renewables are now one of the solutions that countries can take benefit, because I'm sure that in any country or in a region, we can find solar energy, wind, or other renewable resources like geothermal or even waste. Yes, but where we are now, in 2018, the fuel shares in the world total energy supply was dominated by fossil fuels, by oil, coal, and natural gas. Renewables, the share of the renewables was 13.5%, including hydro, biofuels, waste, and unfortunately, solar, wind, and other resources are far behind, just with 2% of the share of renewables. Yes, as we will talk a lot about all the sectors, so we have to know also where we are regarding the introduction for renewables in the sector. For residential, it was in 2018, the same reference year for me, 39%. In the electricity plant on the power sector, it was 37.3%, the industry 10%, and the others, yeah, as you say, is more or less 5, 3, and 0.5 for heat plant, for example. That was, I think, the statistics from IEA from this year report outlook. This is the renewable electricity cumulative. In this graph, we can see that last year, we reached 2.5 terawatt. It's 2,532 exactly gigawatts. So we can see that there is an increase in the cumulative capacity. But what about the impact of COVID? The impact is real. We can see it in this graph. That's the renewable energy, electricity. The capacity of renewables has declined by 13% in 2020 compared with 2019. So this is the first, fortunately, downward trend since 2000. And for the forecast, we can also predict, as IEA also, mentioned in its report, that for next year we will have the same level as for 2019. That is, I think, very important to highlight this, because we have now some difficulties and challenges, and we have to tackle those challenges, and we will succeed, inshallah. For MENA region, as we are talking a lot about MENA region, now we have more than 28 gigawatt, I think, but as we have to compare with the same year reference, 2018, it was 28 gigawatts, the capacity installed across MENA region, which 21 gigawatt from hydropower. Renewable energy represent 7% of the region power generation capacity and 1.2% of the global renewable installed capacity. In Abu Dhabi, it was, I think, a solar deal record. So they reached in this really interesting project 1.3 or 1.36 cents dollar per kilowatt hour, and the electricity demand in MENA region is rising about 5% at a year, which appear to speed up renewables uptake. So we are below the expectation in MENA region, just 7%. Globally, as we mentioned, is roughly 33%, representing, this the percentage is about the electricity capacity. So the MENA region is still at the inception phase. But there is some, the countries that they are leading, in the MENA region, like UAE, Morocco, Egypt, Jordan, Saudi, and other countries. But unfortunately, others, they are, just at the takeoff, the inception phase. So this is why this percentage is very low. Solar PV and wind are key drivers. This is a fact behind the fast growing share of renewables in the generation of electricity, but renewables share in the building for heating, cooling, rooftop, transportation, and industry sectors lags far behind its potential. That is why we have, this weaknesses regarding the penetration of renewables in the energy balance globally. And acceleration, as I said, of renewable in all the sectors will be needed to achieve the Paris Agreement. So why and how? So we have a lot of scenarios. In some time, there's some contradictions, and from example, we have some ambitious scenario. Like Greenpeace, who is looking for a 100% of share of renewables. IRENA, for its transforming energy scenario, is looking for a 65%, but for example, in the Shell Sky, they are just over a little bit of 40%. So decision makers, they are a little bit hesitating, but they are looking also in some cases to go beyond those scenarios, and we can do it if we have, the right policy and the right resources. The cost is a key driver for renewables, and we can see that, for example, as I mentioned in CSP, we are now already reaching the 1 cent the kilowatt hour, cents, dollar cents, and the prediction is very also optimistic regarding this outlook from IRENA. And in general, all the technologies, the cost of all the technologies are in the limit of the competitiveness with fossil fuel range, and also during the next decade, the prediction that the costs will fall again and again, and that is a good message for developers and also decision makers. The transforming energy scenario from IRENA that I come from, I was there for more than 6 years, and now I am working with the EU GCC network. I wanted just to highlight this transforming energy scenario. As I mentioned, the target is to reach this 65% of renewables in the total primary energy supply. So that is the target, but how we can reach this target. So the plan is to go through all the sectors of the economy and the transport and industry, building, and see how we can improve and how we can also scale up the penetration of renewables in the industry and the transport. Maybe we are struggling there. There's a lot of difficulty and challenges, and there are not easy to get renewables, application on those big sectors. So I think for buildings it's more easier. As my colleagues mentioned, with rooftop, we can also try also to have some combination between solar and energy efficiency, and we can go forward with buildings. But this difficulties, as we can see here in this transforming energy scenario, we can use all the renewables but definitely, I think for the transport and industry sectors, as I was in one of the webinars, Irina and others also stakeholders will revise this scenario because of these difficulties, and they have to be realistic. On this, we cannot go 100% of renewables in transport, for example. So we have to, transform all the, for example, the car fleet in electricity coming from renewables. I'm not sure that we can reach this. So energy efficiency, energy storage, smart grids, and green hydrogen will become increasingly important in the future to tackle those challenges on those sectors. And we have a variety of technologies and concepts that are available, so we can take benefit of them. Energy efficiency with renewables are key driver for the transition, as we can see here in this scenario coming from Arena also. So energy efficiency, we can go with 40% of GHG emissions reduction by 2050. And as we know, energy efficiency had a lot of benefits in energy savings, in saving public budget. We can also go in the industry, and we can also gain on the cost. And that is for sure that energy efficiency will help the introduction of renewables. We have this publication from IEA. It's very important for those that are looking for those energy efficiency measures. And I think one of the key messages is that they are also talking about building an industry, as we have to, see how we can go forward with those, and also the transport in aviation, shipping. So it will become increasingly important in the future. Renewables and storage, one of the enablers. I think Robert already, mentioned this and with more details. But the electricity system is changing rapidly with the large-scale addition of renewables and the storage technology, including the pumping storage, or like Robert called the kinetic energy storage. So it includes also the batteries, the lithium-ion batteries, make it well positioned to aid in integrating these variable resources while supporting grid reliability and resilience. So the batteries, the lithium-ion cells are currently the best batteries for stabilizing and distribution grid because they combine high storage capacity with high charge and discharge. We have the hydrogen is coming as a solution for the long-term storage. This is, I think, very important. And the pumping storage, this is the cheapest one, the cheapest option. As we can see here, for example, if we need, a long-term storage capacity, we can use hydrogen, but also the pumping storage is if we have the possibility, because I'm sure, for example, in Kuwait, you don't have this option, and maybe in Saudi, you have dam, you have a lot of surface water. So, and for the lithium-ion batteries, that is, under 1 or 10 megawatt even. We can go as 10 megawatt, less than 10 megawatt we can use, but also the duration. For example, the batteries is just for a few hours, but while hydrogen, for example, we can have a long-term storage, days, week, even months. So renewable and storage, I think the market now is dominated by pumped storage hydro with 98%. And for the batteries, we have, this variety of batteries, but for the lithium-ion battery is dominating with 48%, and we have also the flywheels with 28%. Comparison of the cost, and there's some prediction, some analysis, and we can see here that the cost will go down, mostly for the lithium ion, because there is a lot of research to improve the efficiency of this type of battery, but also some others with less reduction, and offshore this the pumping storage system more or less will stay at the same cost. So a smart grid, as I mentioned, is one other enabler if we can use it to have more flexibility in the system. We can decentralize also all the resources. We can use direct power users to reduce the losses, and of course with digitalization, because we are using smart meters and smart technology. So that is the enablers, and also the smart grid, it's overlay with the networking technology. Is a two-way communication, so we can have the availability of the electricity linked to users, not only to the supply. So we can learn a lot from the consumer and see how we can optimize his consumption. It enables a rapid and automated incident response. It makes frequency regulation easier for the power companies, and increase also the grid stability and power quality, as also it helps to load leveling. Green hydrogen now, very quickly. Yes.
Thank you. We have 1 minute.
1 minute, okay, I'm finished. Green hydrogen will provide solutions that can apply to a number of sectors, including transportation, industry, and building. And we can see that we have now cars, trucks, that even railways that use hydrogen. We can, use this green hydrogen coming from renewables in all the industry, and also as a feedstock. So it will help a lot to decarbonize all those. The problem with hydrogen now is the cost, but if we can do more effort, that we can, reach the green hydrogen cost with improving, the electrolyzer efficiency, and also having more hours, operating hours, more than 3,000 hours, and we can, reach this 1.5 euros per kilogram. A lot of benefits, and we see that in the region, for example, in Saudi Arabia, they are building this huge green city called Neom. Is the size of Belgium, is huge, and the investment, it's $500 billion. And one of the aim of this mega projects is to produce green hydrogen and ammonia for local market, but also to export. So that is the framework that I'm seeing that we can go with it for the next decades. Renewables, yes, but we have to combine it with energy efficiency, green hydrogen, smart grid storage, and this, I think, without a policy, without a framework, regulations, it will be tough to reach the targets. So the green energy strategy requires, a change in policy, because we have to reform our market to introduce all those new technologies. We have also to promote those new niches, as we saw in the other presentation by my colleagues. Increase the support of research. We have to improve also the awareness of the demonstration project, develop a workforce, local workforce with engineers, technicians that they can operate and maintain those. And also the private sector will have to play a key role to provide and deliver those technologies to the market, and the finance finally to stimulate the clean energy market development as part of the energy transition roadmap. Innovation is sustain and cooperation it's key, I think, as we have to learn from other countries, from the other regions, and this is very important. Thank you very much. If you have questions, we'll be happy to answer. And thank you very much, Engineer Salem.
Thank you.
So it's
thank
up to you.
Yeah, thank you so much, Dr. Mustafa. We have to move to the next speaker. The questions we can have it, at the end of this sessions. We have gladly we have 3 people are raising the hands for questions. We can let them ask the questions at the end of this seminar. Now we'll move to Dr. Muhsen, Dr. Hani Muhsen. He is assistant professor in the German and Jordanian University, and he will talk to us about the smart grid. We are glad to have him with us in this webinar. Dr. Hani, تفضل. You can have the, you need to turn on the mic, Dr. Hani.
Okay, thank you very much, Engineer Salem, and I would like to thank you and to thank Dr. Badr Al-Tawil for the preparation and organizing this webinar. So just today, I will give an overview about the smart grid. So we can see how Dr. Mustapha mentioned the importance of this concept to the power sector in the future, and not only in the future, in these days also. So let me start first mentioning that the grid has remained similar in the last 100 years. But as we know that the integration of the renewable energy resources and the way in which we live, which make consumption increasing every day, this was the main idea behind the concept of the smart grid, or the need of the smart grid. So first of all, let me define what is the smart grid. So there's many definitions for smart grid, but the common definition, it's an electricity network which uses digital and other advanced technologies such as cybersecurity, secure communication technologies, automated and computer control systems in an integrated fashion to be able to monitor and intelligently and secure manage the transport of electricity from all generation sources to economically meet the varying electricity demand of end users. So the definition here includes many factors. First of all, we are talking about the power stage in which we are integrating now a new renewable energy resources in our grid. So also we have now a communication technologies to communicate between the distributed energy resources and the consumers, in which now they have a different definition for the consumer. It's called prosumer, since now they are producing energy and they are consuming energy. So in smart grid, we are looking to the consumer as a prosumer. Also, we have here the cybersecurity issue, since we have a communication and we have a transmission for the data between the controllers and also the consumption and the control signals. So we need to secure our communication system. So therefore, there's a new field which is called cybersecurity, which is try to handle the issues which can arise with the smart grid concept in this time and in the future. So the idea or the main drivers, let's say, behind the smart grid is the rapid increase, as we said, in the demand size due to the overpopulation and increasing scopes in the commercial and economic sectors. Also, there are clear impacts of the conventional power supplies and the atmosphere layers due to the emission of carbon dioxide. Gases become a serious problem, as we can see here that the carbon dioxide is increasing every year. For example, between 2020 to 2018, it was increased around, let's say, 13 gigatons. So this is the main driver behind the smart grid. So the vision of the smart grid is to bring together the existing electrical infrastructure and the computer and communication networks that we have been calling by various names for years. So we have automation, SCADA, monitoring systems, and battery management system, etc. All of these systems will work together to form the smart grid. Yeah, so the communication networks is, as we said, is one of the important layer in the smart grid architecture, and we will take advantage of the modern technologies like advanced sensors, communications, and the advanced control devices to, at the end, to distribute the electricity more effectively all the way from the transmission to the customer appliances. So as Dr. Mustapha mentioned, the power flow here in the smart grid, it's not like the conventional one. We have a two power flow, as we said, from the customer to the grid and from the grid to the customers. Always we are trying to make a balance between the generation and the demand. So this is the main issue which raises always when we are discussing the smart grid concept. So as I said before, there are three stages in the smart grid. There's a power system, and there's the information flow, and there's the power flow. So the power system can be consisted of many distributed energy resources, and also, from the conventional one, like the fossil fuel and the conventional, let's say, resources. The information flow, it will different channels. It depends on the area, the geographical area, and distribution of these TERs, the distributed energy resources, and the distance between the assist. For example, if we are talking in a small area, we will use, for example, the home area network to communicate between the assist and to integrate the components in the smart grid. If we are talking about larger area, then we will talk about using the neighborhood area network or the field area network. For example, if we are talking about a country, we will use the wide area network. For the power flow in the smart grid, it's from the generation and the transmission. And here the two-way power flow, it's between the transmission and the distribution. As I said before, the architecture of the smart grids and always consists of three layers. So without the smart meter, it's not possible, of course, to apply the concept of the smart grid. The smart meters here play an important role to monitor the demand and also in the future to send control signals to the appliances, for example, on homes or in factories to control the assist inside the let's say the homes or the houses or the factories, in order to always to balance the generation and the demand on the grid. So this is the three layers. I will not repeat it again. So here, as we can see in the figure, the first layer is called the power layer, and then the upper layer, it's called the communication layer, in which we use it as a channel to transmit the data between the different components of our grid. And also the highest layer is the application layer, in which we have the controller, and we have also here the different the geographical information system, for example, and the SCADA, the AMI, also the primary control central. So as we said before, there are many channels which can be used as communication technologies in the smart grids. It depends, as again, on the coverage area of these channels. For example, the GSM can be used for data rate 14.4 kilobit per second, and the coverage range is from 1 meter to 10 meter, while the ZigBee technology supports a data rate of 250 kilobit per second, and the coverage area is from 30 to 50 meter. And also here I would like to mention, for example, the benefits of the smart grid for the consumers and also for the environment and for the industry. In general, we can summarize the benefits of the smart grid into these 4 categories. We have an environmental benefits, we have a benefits for the consumers, and we have benefits for the employee and also for the investors. So if we start, for example, with the environmental benefits, which is again as one of the main driver of the smart grid concept, so to reduce the carbon emissions and also to reduce the climate change. So these benefits are achieved due to reduction in losses and the integration of renewable energy resources. So, and also the use of the electric vehicles also will result in reducing the carbon emissions. From the economic side, we have a reduction of electricity prices, and this benefit is achieved due to the interaction between the suppliers and the consumers. So in the smart grid concept, again, we can sell the energy to the grid, and also, for example, when the prices is very high, for example, we can sell the power, and we can consume the power when the prices are cheaper. Okay, this is also one of the benefits of the smart grid, which is the technical benefits. Here we are improving the energy efficiency by reducing the different losses in the system. And this returns to the idea of the decentralized, as Dr. Mustapha mentioned, that we have now a few blocks, for example, which form the smart grid. And this block, we can call it the microgrid. So within the microgrid, now the distance between the consumers and the distributed energy resources are smaller than the conventional power system. So we will use smaller cables, and this will result in reducing the power losses in the power system. Also, we are improving the grid reliability. So as we will see later, is one of the advantages of the smart grid. It's called the self-healing. For example, if we have a blackout in one area, this area can be covered by energy from a closed area without sending, for example, the maintenance team to solve the issue, for example, directly. Yeah, this is also will increase the reliability of the grid. Also, we are improving the operational efficiency by using active control and automation and management services. Also, we are improving the security and the safety by reducing the threats of the blackouts and by reducing the vulnerability of the grid to unexpected hazards. Yeah, and also improving the quality of the supply by maintaining the voltage magnitude within statutory limits, and also improving the access to the grid for the distributed energy resources and the electric vehicles. Yeah. So the smart grids must have these components at the end. We must have, for example, energy storage devices, and mainly if we are talking about on the microgrid level, if we are talking about the islanded microgrid, which is talking, we talk about, for example, some area which is not connected to the grid. And in this area, we will supply this area from the renewable energy resources. So it's not possible to compensate the reduction of the generation using the power grid. Then we need to use the energy storage devices. We have the local power generation. We have the concepts of digital sensors and controls. We have real-time data. We have real-time price signals, broadband communications. We have smart homes, smart buildings, and electric transportation. All of these components will form the smart grid. Yeah. So here again, there's a movement to make the energy grid smart, which means that we need to add layers of intelligence to the conventional grid. We need to make a multi-way communication. So in order to make our grid able to be to make self-healing, self-balancing, and self-monitoring. Self-healing, we explained it before, that, for example, if there's a blackout in some area, which can be solved by transferring energy from a close-by microgrid, which can transmit the excess energy to this area. And we have self-balancing, for example, if there are, let's say, an excess in the consumption or in the demand. So here, for example, we can make the balance by, first of all, increase the generation or to reduce the load. So here we always to make a balance or to make a management between the demand side and the generation side. And also we have a self-monitoring. We have here a controller and we have meters everywhere in the smart grid. So we will be able to detect the errors before it happens and also to monitor the situation in our grid. Okay. So it's not more than just smart meters. So the smart grid, not only adding the smart meters, it also includes real-time monitoring, transmission and distribution automation, the demand response, the broadband over power lines, and also integration of the renewable energy resources. Also include the involvement of the energy storage, and also we will have smart buildings and equipment. All of these ideas, it must be included in our grid to be called smart grid. So now what's the difference between the current situation of our grid and in the future with the smart grid? For example, the utility doesn't know when power is used. With the smart grid, the utilities will offer lower rates for using the power in off-peak times. So for example, if you want to use, for example, the wash machine in the home level or the house levels, for example, if it's on the, let's say in the mid of the day, then the prices, it will be very high. So you will not use it if you know that the rates will be cheaper in the evening. So this is one of the options which you can make a load management in the future or in the smart grid concept. So here we can move, for example, when we get a large blackout, here the grid will automatically create a fire breaks fast enough to stop them because it can predict the faults before it happens due to the measurements which we have it in everywhere in our grid. Yeah, there are many points. I cannot mention all of them here due to the time limitation. So again, the smart grid city, it must involve the entire energy pathway from the power source to the home and all points in between. And it's rich in IT. There's a high-speed real-time two-way communications. We have sensors that enabling rapid diagnosis and corrections. We have energy storages. We have also automated home energy use. Yeah, so this is the main idea, let's say, about the smart grid. And here we are mentioning the role of each component, for example, of the smart grid by assuming different scenarios. I will just mention, for example, two scenarios due to the time limitation. For example, if we are talking about the energy storage, we will use, for example, the energy storage for wind energy to store it, for example, for a time in which we will use this power in our grid. So also the consumer can use wind power when they want, not just when the wind is blowing. And energy storage devices can be tapped whenever the demand is high. For example, if we are talking about smart substation, for example, here the scenario, the digital intelligence gives substation operates remote control of facilities, which allows faster adjustment to conditions, and it prevents blackouts, makes for faster recovery. We have more flexibility to reroute the power. We have also here the ability to monitor, helps keep facilities and sites secure. So there are many different scenarios which we can, for example, share the slides with the attendees if they are interested. So finally, if we're talking about the smart houses, also the smart houses in the future, it will include controllers in which you can control it as a person who lives in this house, or even the company will also have the power, for example, in the future to control the load by disconnecting some loads if there are a lack of generation in contrast to the demand side. And also, yeah, also these devices will be connected to the internet. As we know now, it's the revolution of the IoT, and yeah, it's the era of the industry 4.0. So all of the components will be connected to the internet. So this is also will ease the task of the smart grid concept. Yeah, also it's important to mention here also the plug-in hybrid electric vehicles and the electric vehicles will play an important role, for example, in the smart grid concept due to the use of their batteries, for example, for energy storage. So for example, if you have energy stored in your car battery and you want to sell this energy, you can sell it. So also they are depending on using this energy in the future to complete the operation of the smart grid concept. So let me say this was the main things I wanted to mention quickly as an overview for the smart grid concept. So thank you all for the listening, and if you have any questions, I'm happy to answer it. Thank you very much.
Thank you, Dr. Hani, for your presentations, and you are doing good time management for that. We appreciate it. And also, now you are talking about the smart grid. Maybe the people think that it is alternative now, but in the future, it's going to be necessary for the countries, to get better management for the electricity, and also the evolutions of electrical vehicles. We have to manage that, and we can't get advantage of that without having the smart grid in our network.
Let's say in our area, it's the future, but in Europe, they started already in this concept, applying this concept.
Yes, and especially the load management. I was in Glasgow, Scotland, and they already have the smart meters, and they are doing some incentives for the load management. If you shift your load, you will get better tariffs, and I hope we can reach that in our countries, inshallah, soon.
Yeah, inshallah.
Thank you.
Especially this country, they set a target, for example, with zero net carbon in 2030 or 2050.
Right, yeah.
This is also will accelerate the smart grid concept.
Yeah, thank you.
Thank you very much also.
And now we'll move to our next speaker, Mr. Omar Massoud. He's the chairman of the Green Global Power Company from Ireland. We are glad to have him with us in this webinar to talk to us about in-pipe energy and some other technologies that the company can offer. And yes, we are happy to have him. Mr. Omar, تفضل, you can start your presentation.
Assalamu alaikum, everybody. I want to thank you, Mr. Salem, for inviting me to this seminar. Thank you very much. And I would like to share our screen here. I'm just going to begin with an introduction, and I'm going to have a video for the product that I'm going to talk about, because we have different products in our company. So this product managed to catch your attention, Mr. Salem. So, if you can just set the screen for me, please. Just put the video there. Sorry, Mr. Salem, I just want to put the video there.
Yeah, that's fine. Take your time.
Thank you so much. Can you see the screen, everybody?
Yeah, we see the presentation, not the video. You can, yeah.
I'm going to play it back for you guys so you can hear it. This is our product called Imbibe Hydro, and I will explain to you what it is exactly after the video.
Okay. Maybe there is no sound, I think, if you have sound.
There is no sound, yes?
Yeah. No sound.
1 second.
I think there is a way to connect your computer sound, to enable the sound. I'm not sure how.
Okay, give me 1 second. I just get my secretary to do that. So, Mr. Salem, I'm going to explain to you what it is, because I'm having a bit of difficulty to, get the sound connected. So this is a product we developed, and we built a project in America, California, called Imbibe Hydro. So basically what it is we are replacing PRVs, pressure reducing valves, and they are used basically to get rid of the pressure in the water pipes, so the water pipes don't break. And we are replacing them, and we are generating renewable energy from the pressure inside the pipes and the water flow. And the difference between this technology and other technology like solar, wind, geothermal, like it's 24 hours, 7 days a week, non-weather dependent, and you can generate energy, renewable, clean energy from that. So basically, what we invented here and we implemented in Kenya and San Francisco, this new idea where you really don't need storage. It's basically generating renewable energy from pipes, and it's an attachment to existing pipes. So, can you hear me, Mr. Salem?
Yes, I can hear you. Yeah, it's very
yes. So I'm gonna just show you some of our products. So this is some of our products that we've done.
Yeah,
one of them is CSP, water purification and aquaponics system. So we integrated.
You need to switch the screen share to the presentation. Now it's...
Oh, sorry about this. Give me 1 second, sorry about that.
Yeah, it's now we can see it.
Okay, so this is our products. One of them, the first one is CSP, water purification and aquaponics system. So what it is we are basically, everybody's familiar with CSP, but what we did here is we have water purification. We are converting seawater to pure water, and we are using it in agricultural, and we are using aquaponics. And aquaponics is basically hydroponics that are connected, fish farming and hydroponics together. So all of these are major products we've worked in Australia. And we have, as you can see here, all the facts, the project facts. And, basically what the difference between this agriculture is you are saving 90% of the water. And, and basically you have renewable energy for 24 hours as well. So I'm gonna go in to the next page there. This is a bit of a description about Imbibe Hydro. So it's a solution for public and private water system to reduce 70% of the energy cost and establish a smart, sustainable water grid infrastructure. So basically, our solution addresses like 4 to 36 diameter pipelines, and it's called F2W, flow to wire. So basically, what you can do is we can generate 750 kilowatts from the flow of the water and the pressure, and this energy could be used to the factory, or you can sell it to the grid. And we have two options. We can install them or we can rent them to water factories. So this is an amazing idea because it's non-weather dependent, and you're talking about green energy 24 hours, 7 days a week. It's very different and unique. And basically that's what Imbibe Hydro is, to be honest, and we also, everybody's familiar with the, geothermal as well. We provide geothermal energy, we provide solar, but this product is very different and unique. And
Mr. Omar,
yes.
You say it can produce 50 to 700 kilowatt. Can you go back to the slide?
Yes, no problem. I'll go back and I'll show you. Yes, so for large sites, you're talking from 35 kilowatts to 750 kilowatts. That's almost a megawatt, and you can custom engineer a solution for large sites, And for small size, you know, we're talking about from 5 kilowatts to 30 kilowatts, you know.
This is the diameters around 4-inch to 36-inch.
That's right, yeah.
Whenever
it's a standard pipe, it's a standard, you know, sizes for pipes usually used worldwide.
And this, if we have like a large diameter pipelines, like 36-inch, we can produce like 750 kilowatt an hour, right?
That's right, yeah.
Yeah, and this is using some turbine, like vertical axis turbine, right?
We are using, you know, pressure, and we are using also our generator as well. It's an attachment instead of PRVs, pressure reducing valves, and we replace them with our generator. We're converting water flow, and water pressure. So we are using the water flow and the water pressure as well.
And producing the water pressure, how did you produce it?
How do we produce?
Yeah,
sorry,
but
say that again.
The water pressure, how did you produce it? By using some valves and some techniques on that, huh? To increase the pressure?
Well, yeah, yes. Well, basically, our generator, you know, it's, you know, we basically, you see, if I go back to this, if you go back to this, yeah. So we are using basically the flow of the water. We are letting it come into our generator, and we generate an electricity from that, and we're using the pressure from that to generate renewable energy. And you already send in the water to the public, and a lot of people not taking advantage from this. And it's 24 hours. And we all know the biggest cost for water is energy. So what we did here, we are generating energy from the water, basically, and the flow of the water and the pressure. So if you're talking about...
Yeah, it is very interesting because, you know, in Kuwait and in some other Arab countries, we have a large network of water pipelines, and they are in the huge diameters, and they are in different. When you are producing some energy from that, that means, you know, this is a very great things to have as projects and as the productions of energy. Mr. Omar, are you there?
Yes, sorry, yes, that's right, Mr. Salem. So, you know, water factories exist all over the world, you know, and basically the biggest cost for the water, you know, in the Middle East is, you know, there's systems like MSF, multi-stage MSF, and reverse osmosis. And what we're doing here is we are waiting for the water to be purified already from the water factories. But when the water is purified and is being sent to the public, we come in here and we replace existing valves with our generator. And we are generating renewable energy that could be harnessed from the pipes, that can go back to the factories, or you can sell it back to the grid. The difference between that technology and other technologies is huge. It's non-weather dependent. You're talking day and night, you know, 24 hours, 7 days a week. And it's a replacement, and it doesn't cost a lot. So yeah. I really believe, like, I've been in the business, in the renewable energy business, for 15 years now, and I've dealt and I worked all over the world with a lot of projects. This product is a game changer, to be honest with you, you know, and it gets rid of the storage problem, you know.
Yeah. Thank you, Mr. Omar, for this show, and it's to present this interesting applications and technology. And I think people will appreciate it and can look for it in the future, in the near future. And now we can move to our next speaker.
Thank you very much.
Thank you, Mr. Omar. Thank you.
Thank you so much. Thank you.
Thank you, appreciate. Our next speaker is Mr. Franco Cioffi. He's from Italy. He's the chairman of Sunstream company to talk to us about the solar solutions that they have. I'm sure he will show some interesting solutions in his presentation. Mr. Franco, you can start your presentation, and sorry for being late to you.
No, that's all right. That's all right. Hello, good evening, all. Thanks again. I will. I think I'm the last speaker, so I promise I won't take up too much of your time. But thanks again, Mr. Salem, for giving me the opportunity to come and join you on this very interesting webinar. So thanks to all the speakers. I'm just going to share my screen. Can everyone see that?
Yes, yeah.
Okay, like Mr. Salem said, my name is Franco Cioffi, and I'm the Global Director for Sunstream International. I'm here today to talk to you about the innovative, autonomous, mobile, plug-and-play solar solutions that we have designed over the past 6 years and manufacture in our factory in Germany. Given the remarkable recent technological developments in the renewable energy industry and the ever-increasing number of problems arising from climate change, I firmly believe that one of the next major industrial revolutions will take place in the energy sector. So we are now in the process of switching to a new era of green, mobile and decentralized energy through many parts of the world. Our ambition at Sunstream International is to become a world leader in the manufacturing of mobile solar solutions for decentralized renewable energy production. We have developed a wide range of containerized
Yeah,
Hello?
Your slides are not moving. Are you moving your slides?
Oh yeah, this is just my intro, apologies. This
Okay.
is just a little intro, yeah.
But you are changing the slides. Okay, you can go ahead.
Yeah, no worries. Yeah, we've developed a wide range of containerized mobile solar products that are quick to install, come with a pre-fitted control room, and require no civil engineering works, and can work on or off grid. So in the next slide, I'm going to show you a little bit about our past. We have been in the industry for over 15 years. And in the past 10 years, we were focusing mainly on rooftop solar installations and the classic ground-mounted system. This was our experience before we created Sunstream International. So as you can see, and the photos on the top of the page are from an installation that we did for a 3.5 megawatt PV rooftop solar power plant. At the time, it was actually one of the biggest in France. As you can see from the pictures, it required a lot of resources, machinery, and time, all things that add to health and safety risks, which are obviously paramount, and costs to a project. On the bottom of the screen is a picture that was taken from our project. It was a 2.5 megawatt classic ground-mounted system in Brasov, Romania, that supplied over 3,000 households. So it looks your standard classic ground-mounted system, very good, very efficient. However, it required several pre-construction activities such as planning permissions, ground penetrating surveys, and grading works, to level the ground, which unlike our products at Sunstream, which are now mobile and a lot more flexible. In order to provide a better solution than the rooftop and classic ground-mounted systems we installed in the past, we at Sunstream decided to create a new world of autonomous mobile plug-and-play solar solutions that would allow faster installation times, improved mobility, and reduced labor force. All of our solutions have the same DNA, really. They are fully pre-equipped and wired, and they come with a control room that it operates in the actual container that the product is delivered. They are intelligent systems that can be installed in a few hours. Some of our products can be installed only in a few hours, to a maximum of maybe a few days, depending on obviously how many kilowatts you can install. I'm now just going to show you a video, which is it's our company video, and I think it kind of showcases our products really well. It just gives you a little bit of an idea of what we've created over the past 6 years. And obviously, you know, these can be used for on or off-grid locations. It does come with music, so if you don't hear it, let me know. I think I switched on the sound, so it should work. But you know, Mr. Salem, please let me know if it doesn't come through.
Okay. Yes.
So that's our company video. Now here you'll see a range of some of our products, some actual pictures from real pictures of actually the products on site. So on the top left, you'll see our build box, which is a multifaceted, waterproof, quality aluminum structure. And its ideal solution is for storage space, which is clearly visible in the picture, or we've actually sold it for use as a classroom in Africa, in Senegal. We sold it to a client there. They used it as a schoolroom classroom, or it could be used in camps, like such as military camps, or even as event spaces, you know, maybe for big events, you know. It can, a 20-foot container can hold up to 5 of these kits. There's 4 there in the photo that you see, which can be installed in 5 days. So basically it takes 1 day to install each kit. And you can create about 60 square meters of space with 1 kit. So that will give you about 12 kilowatt peak. The next product, the ground box, is actually our newest product, and it's really a kind of semi-mobile solution to the classic ground-mounted system that we previously installed. We only developed this a few months ago, and it kind of came out really after, you know, a brainstorming session, after like many conversations with clients which were interested in the wing box that you saw in the video, which is this foldable solar solution. However, it can be a bit pricey and it can be a bit difficult to install for bigger solar plants, like in the megawatts. So we decided to kind of create this new product, which could be easy to install. It could actually withstand higher winds. I mean, this product can withstand up to maybe 300 kilometers an hour winds. And it's basically, as you can see in the picture, the solar mounting structure is fitted on top of metallic boxes, which are then filled with local sustainable materials such as rocks or sand, depending on what is available. In a 20-foot container, you can transport about 30 kilowatt peak, which can be installed in only 40 hours. So again, very, very quick installation times. The next product is the wing box. Like I was saying, it's basically, it's one of our most mobile products, and it's a foldable solar wing that is made up of 8 panels, as you can see in the photo, and it can be installed. Each panel can be installed in 15 minutes, so very quick, you know. So a 20-foot container will probably hold between, I would say, approximately 25 to 30 solar wings, which can provide about 80 kilowatt peak, and can be installed in only 1 day. So if you can imagine, you could have like maybe a 1 megawatt solar plant. You could install it in 10 days. So, you know, a lot faster than what we could previously do with a classic ground mounted system. The next product is the Oryx Box. It's basically a solar trailer. It's, of course, our most mobile product, because you can just connect it to the back of your vehicle and you can just drive it anywhere. We've kind of designed it with the idea of replacing the noisy and environmentally unfriendly diesel generators that we've been accustomed to use. The one you see on the screen there is our 12 panel trailer, which is our smallest one. It comes in 3 sizes. We have a 12, 18, and the 36 panel, which I mean, I stand corrected, but from what I've seen, I think it's the biggest trailer available on the market, which is a little bit of an achievement there, I guess. So that's a very good product, and it's a fully integrated conversion power system that includes the solar panels, as you can see, a lithium-ion battery, and an inverter. It's all installed underneath the panels on the trailer. So you can drive that around, and you can literally, you can open the trailer, one person can operate it, and in 10 minutes you can start producing your energy. So on the bottom there, the 2 products on the bottom left, the water box and the charge box, I'd like to talk about them. I think they seem to go well together as a solution, and the reason I say that is because we have in countries now that we're facing these challenges of clean drinking water and electricity, or lack of clean drinking water and electricity in countries such as, in African countries predominantly. These are solutions that can provide you with basically drinking water with the water box, and the charge box is basically a system where you have 100 batteries. You have the solar panels as you see in the photos there, and they charge the batteries that are inside the container, and then those batteries can be rented out to the local user in the form of effectively the container becomes your shop. So you can rent out the batteries for, that can be used for maybe a small office at home, or limited lighting at home, etc. And you can combine these two products together, and effectively you could be selling clean drinking water and also renting out electricity. So it works as a great business model opportunity for the local user, but more importantly, it can help a village, let's say a remote village, be sustainable, into the future. So, two very good products that we've sold. We've sold a few in Africa. We did one in Burkina Faso actually, where they did the water box, and we've done the charge box in a few different countries as well in Africa. So, two really great products, I think, that work very, very well together. And finally, the DEX box, as you see there, it's a fully integrated, movable, plug-and-play off-grid solar system that can basically be connected to the top of any container or adapted structure in a matter of couple of hours. So very, very quick. It can give out about the 6 panels, so you get about 2.5 kilowatts or so. So it's not too much energy, but it's sufficient for solutions like, maybe on construction work sites where you have containers as office sites, or storage facilities, or maybe military camps, etc. And again, as well, you can see in the little box near the gentleman in the picture there, that's where you would store the inverter and the battery systems. So these are some of our products. Of course, we have some others that you can have a look on our website. Yeah, I mean, thank you very much for taking the time to listen. And yeah, if you've got any questions, you can either reach me on my mobile number there, or email, or happy to answer anything else.
Yeah, Mr. Franco, can you go back to
Oh, sorry.
That's all right. You can go back to the 6 pictures you have, or 8 pictures, the solutions. Yeah, this one.
Yeah.
When you say the charge boxes, what type of batteries you are using in this?
The batteries.
Yeah.
They are, hold on.
And
I actually, yeah, I don't know.
I think lithium.
I don't know exactly what type of batteries it is. I know we've recently kind of upgraded this solution, because what we sold in the past was a little bit different, and it worked a little bit different, and we've kind of improved it. So I recently got some information about the prices and the actual product. So I don't really know I haven't got the specifications to hand of the batteries, but I can definitely find that out and let you know if you're interested.
And actually your solutions are very important for the projects that are working in the remote area, or in the desert,
Yeah.
such as the wing box and the big box. So I think it's very important, as a solutions, you put it in the way that it can be very useful for the community and to the governments. Also, you have the water box. The water box is something is very it's helpful for the communities, like in Africa and also in the other countries that they have lack of water. I think in GCC and Arab countries, they suffer from the having the water, the drinkable water. We all the time using the desalinations from the sea, and this is small solutions that can do the desalinations is very good for our communities. Thank you so much, Mr. Franco. And now we will go through the questions. We appreciate your time, Mr. Franco. Thank you.
Thank you.
Now we have Mr. Jamal Wahib. If he's still there, we'll listen to his questions. Mr. Jamal. Mr. جمال, you can press to the space, يعني اضغط على مسافة حتى تقدر تتكلم. Mr. Jamal. We'll go back to Mr. Khalid Faraj. We'll see if he is still there. مستر خالد تفضل. ما نسمع مستر خالد. المايك كان شغال بعدين طفيت أنت. Okay, anyway, we'll go to some questions. Mr. Omar, if you are there, Mr. Omar.
Yes, Mr. Salem. Assalamu alaikum.
There is Mr. Muhammad Magatif. He's asking the question saying, does your solutions affect the water pressure? And what is
Absolutely not.
And what is
yes.
What is the parameters you consider when installing the solution? What are the parameters he has asking?
Yes, basically our solution it doesn't affect the pressure at all. It doesn't affect the pressure or the flow of the water. Our generator does not affect the pressure, or it's a replacement for PRVs. So every pipe have a valve attached to it to reduce the pressure, because if you don't reduce the pressure in the pipes will explode. So that's one of the costs for pipes of the water. So what we did here, we came up with a generator that could replace the valves and get rid of that excess pressure that already damaged the pipes, and we generate renewable energy from it and from the water flow. So it does not reduce it reduces the pressure and convert it to energy. So it basically uses the problem as a solution. And also our solution addresses from 4 to 36 diameter. And that's the standard pipeline sizes, from 4 to 36. But for large water factories, we will custom size a solution for them.
Okay, so you are controlling the pressure, so there is no worry about the damaging the pipes.
Absolutely. I mean, the companies already spend millions of dollars just to get rid of that problem. So we are replacing this valve with our generator to harness the pressure and convert it to renewable energy. And also we are generating energy from the water flow in the pipes, and it's non-weather dependent. It's non-weather dependent. And you're talking 24 hours a day, renewable energy. Mm-hmm. It's very, very different and very effective. And, I worked with a lot of products in the past. I dealt with geothermal, I dealt with solar. I have a lot of projects in America and Africa, even in the Middle East, But this product, from all my experience, is the solution, to be honest, you know, because the biggest cost for water is energy. And, you know, you're talking generating renewable energy, you know, from the pipes that already sends the water to the public, you know, so, and it's an attachment, is a replacement, is not a big deal, you know. And we already implemented this, just to clarify, because earlier on, I couldn't really put, you know, my presentation. We already installed this in California, and we already installed this in Europe, in Ireland, and we did it in Kenya and Africa as well, and it was a successful project, you know. So it's not a theory, it's been implemented and it's been tested.
Mr. Salem, I have a question, please.
Yeah,
Mr. Omar.
Yeah, تفضل Dr. Hani.
Mr. Omar, I have a question about the material from which you made the blades of the turbine, because maybe this will make a contamination on the water and it becomes, for example, it's not drinkable or something like that. What about the material?
Absolutely. The material, you know, I will send you the details exactly. If you want, if you can leave your contacts and everything, I can show you the website, every single details, to be honest with you, if you want, in full the details. But it will, when I answer your question directly without going into details, we, you know, every country we went into and installed this, you know, there's water regulations. So it would not be possible to install this in these water factories if it's going to affect the water, you know. So it's been approved, and it's, you know, I can send you the information of the details later.
Okay, thanks.
Thank you. And yeah, thank you. And there is questions for Dr. Mustapha, if he is still there, Dr. Mustapha.
Yes, Engineer Salim, yes. Still.
Yeah, there is Mr. Riyad Al-Qabakli. He's asking about, what about energy from the waste in Arab countries? Do you have any information about that, Dr. Mustapha? Oh, what's the
yes.
Is it it has a potential there?
Yes, regarding the potential, yes, it's a huge potential. Imagine if we can use our municipal waste, you know, the waste coming from our houses. So we can use it. We can, you know, have two options technologically speaking. We can have the biogas, and we can have electricity. Then we can have heat. We can have electricity, or both. So it depends. In the Arab region, unfortunately, we are not taking advantage of this waste. Still at early stage of development. I know that, for example, in the Emirates, in Abu Dhabi, there is one plant, one project underway. So it's a pilot, but I think the technology is now very competitive and mature. We have just to Google it. For in Europe, for example, there are a lot of megawatts coming from those waste plants. We have also a couple of other projects in Morocco. So I think now it's because the problem is not in the technology, but because the waste management in our country is very complicated. Is not under the utility, is not under the Ministry of Energy, is under the Ministry of Interior, or I don't know, for example, in Kuwait, who is dealing with the waste. So you have to deal with those multitude of actors who will be doing what. So I think it's on the governance side that is struggling to get that. But I think with the successful implementation of this pilots, I think in the UAE and in Morocco, I think I heard also in Tunisia, maybe in Jordan, I'm not sure. So everybody now is waiting, you know, for the result of this. It would be in the pipe in the next few years.
Yeah, thank you. And I think we have in Kuwait, we are supposed to have our waste to energy station, and it was supposed to produce like 60 megawatt of power. and they announced about it in 2017. But as you said, Dr. Mustapha, the waste management, it's very complicated here in Kuwait, and they cannot assure the quantity of the waste that can produce this much of energy. There is no controlling for that waste. And that's why they postponed it for later on. We hope, you know, they can do the better waste management in our countries, so they can get advantage of the waste to energy process. Thank you, Dr. Mustapha. And yeah, I think we reached the end of this webinar. We're sorry we took like 30 minutes extra time, but I hope you all enjoyed the time being with us. And the special thanks to our speakers, Mr. Robert, Mr. Saeed Balhadad, Mr. Dr. Hussain Bassi, Mr. Ahmad Alazmi, and Mr. Dr. Hani, Mr. Franco, and Mr. Omar. We all thank you guys for being with us, and our special thanks to the Arab Union for Sustainable Development and Environment, Dr. Ashraf Abdulaziz, and the Arab Council for Sustainable Energy for supporting us to present these seminars and webinars. Also, the special thanks to our audience who stay with us all this time, and I hope they get any good information and they enjoy the time. Regarding the presentations, I think it's better to contact the speaker himself. They can gladly present to you the presentations. This webinar is recorded, and I will try to publish it to my YouTube, and the videos will be ready for anybody who would like to get a copy of it. And again, I hope you enjoy your time, and we can say you can have a good night now after a long time with us in the webinar. Thank you, guys.
Thank you very much.
Thank you.
Thank you. Bye-bye.
It was a pleasure. Take care. Bye-bye.
Bye-bye.
Bye.